we already know that I mean it looks okay-ish, you know, for now. until maybe it starts to misbehave. So anytime you see stuff like this, right? Yeah, you just want to be a bit careful. I think in the what you may call in that trigonometry revision playlist. The funny thing is the kinds of questions we're going through now, right? The fortunate thing is when we are done with these questions, right, you'll be able to like get more of this kind of revision from that trigonometry revision playlist that I mentioned. So here, as you said, right, we need a lowest common denominator.
Yeah.
So an LCD here is not going to be a hassle because I mean, like, you know, it is what it is. Just gotta get it and we just gotta go. So let's see here, right? Let me do this. LCD is here, lowest common denominator is this times that. 1 plus sine x and then cos x without overthinking anything. So this we would need to multiply it by cos x over cos x. Yeah, let me write it a bit clearer, you know, it really doesn't have to be so weird looking. So we said here, this, I mean, getting an LCD, we know we just have to multiply it by cos x over cos x. And then for this one, we have to multiply it by 1 plus sine x over 1 plus sine x.
Yeah.
Yeah, so we're gonna try this out. And then if it doesn't work, then we'll have to showcase something different. So let's see here, cos x times cos x is giving us, I mean, cos times cos is cos squared x. And then here, this is gonna be plus. Here you have to be careful now. You see, brackets are important because this is one thing being multiplied by,
Yeah.
you know,
Should
that.
be 2 plus sine squared x.
Well, I mean, for now we can just literally put just two brackets next to each other so that we can just do it slowly, you know, bit by bit, without feeling as though we're being rushed. And then our LCD, we got it to be this thing here, 1 plus sine x multiplied by cos x. Now we can FOIL. You see at the top, the cos squared x is just the way it is.
Yeah.
It's like 1 times 1, which is like 1 times this, which is like sine x, and then sine x times 1, like sine x, and then sine x times sine x, sine squared x. You see, and then it says here cos x times 1 is okay. Let's leave the bottom for now. The reason I say let's leave the bottom for now is, I mean, usually if there's no reason to change the bottom, I mean, like, you might as well leave it for now. Because what we know is eventually we need like a sine, what does it say? We need like a cos x at the bottom. So we'll see how we'll get that. If this is not working, we'll have to showcase a different way to tackle these kinds of questions. So far, let's see, we have here cos, you see this cos squared x here?
Yeah.
And this sine squared x there.
Yes, that can be a 1.
Yep, that can be a 1. And then here plus a 1 here, let's just maybe not write it too fast. So let's just do what we can here, sine x with a 2 there, because there's 2 of them.
Yeah.
At the bottom, we have cos x, 1 plus sine x. So I think here this question is going to show why we may not want to like just distribute this cos unnecessarily. Because at the top, you see, luckily we have a 2 here and a 2 sine x over here. Of which, what do you think we would need to do next for this question to work out?
You can't cancel anything. Can't that 1 plus sin x change?
Well, Well, remember, when you're thinking of canceling stuff out, right? When you see you cannot, you ask yourself, what can you do to make this expression in such a way that allows you to be able to cancel?
Factorize.
Yes, away. There we go. There we go. We can
Mhm.
factorize the top, by taking out a common factor, which is the
Which
2
is
here.
2.
Yeah. So if the 2 goes out, we're gonna have 1 plus sine x. Down here, this is like cos x, 1 plus sine x.
And then
Like
they
that.
cancel out. Then you get
Yes.
2 over cos x.
Yes. Then this cancels that. This cancels this, which is just gonna be 2 over cos x.
Okay. That makes sense.
Yep, fantastic, fantastic. So yeah, this is the kinds of stuff you'll find in that trigonometry revision playlist. Let's actually go and check it out and see what's there. Just